How to disable X-frame options response header in Spring Security. This follows the same teaching style as your earlier Spring Boot topic. Introduction. In Spring Security, HTTP security headers are added automatically to improve application security. One of these headers is X-frame options. This header is used to control whether your web pages can be loaded inside a frame, iframe, or similar HTML embedding element. Sometimes developers want to disable this header, especially when using the H2 database console, embedding the application inside an iframe, working with internal admin tools, testing framed content in development. A very common question in Spring Security is, how do I disable the X-frame options response header? Understanding this is important because disabling the header can solve some development problems, but it can also reduce security if done carelessly. This topic helps learners understand what X-frame options is, why Spring Security adds it, why you may want to disable it, how to disable it in Spring Security, when it is safe and when it is risky, better alternatives in some cases. This is a practical and important Spring Security concept. What does X-frame options mean? X-frame options is an HTTP response header that tells the browser whether the page is allowed to be displayed inside a frame or iframe. In simple terms, X-frame options equals browser protection against unwanted framing. It helps protect against clickjacking attacks. Example concept: website page loaded in hidden iframe means user clicks something without realizing it, means attacker tricks the user. This is one reason browsers and frameworks care about frame protection. What is clickjacking? Clickjacking is a security attack where a malicious site places your application inside a hidden or misleading frame and tricks a user into clicking something. For example, a user thinks they are clicking a harmless button, but actually they are clicking a button from your real application hidden underneath. Example concept: malicious page means embeds your site in iframe, means tricks user interaction. To reduce this risk, frameworks often prevent pages from being embedded in frames. Why Spring Security adds X-frame options? Spring Security adds security headers automatically as a protective default. X-frame options is one of them. In many cases, Spring Security sends X-frame options deny, or sometimes a related restrictive configuration. Example concept: Spring Security response means browser receives frame protection header, means page cannot be embedded. This is done to improve security by default. Why you might want to disable it? Sometimes the header blocks legitimate use cases. Common examples include opening the H2 console in a browser, embedding your own application inside an iframe, using internal dashboards inside framed layouts, testing UI integrations that depend on frames. Example concept: app needs iframe support, means browser blocks rendering because of X-frame options. So, developers may want to disable or relax this header. Common example: H2 console. One of the most common Spring Boot examples is the H2 console. The H2 database console often uses frames, so Spring Security may block it. Example concept: H2 console loads means browser sees X-frame options restriction, means console fails to display properly. That is why many developers first encounter this issue while enabling H2 console. Is disabling X-frame options safe? Not always. Disabling this header reduces protection against clickjacking. Example concept: no frame protection means malicious site may iframe your app more easily. So, the important rule is, disable it only when you truly need it, and ideally only for development or trusted cases. For production systems, blindly disabling it can be risky. Basic way to disable X-frame options in Spring Security. In modern Spring Security configuration, you can disable frame options in the HTTP security configuration. Example: @bean public security filter chain HTTP security HTTP throws exception. http:/headers, headers.frameOptions.disable. Return http.build. Example concept. Spring security headers config means frame options disabled, means X-frame options header not sent. This is the standard way in modern Spring security. Full example with security filter chain. Import org springframework.context.annotation.bean. Import org springframework.context.annotation.configuration. Import org springframework.security.configuration.web.builders.http security. Import org springframework.security.web.security filter chain. Configuration public class security config. At bean public security filter chain, HTTP security, HTTP. So, HTTP authorize HTTP requests, auth any request authenticated. Headers frame options disable. Return HTTP build, app, example concept. Security config means frame options disabled, means browser no longer receives X frame options. This works in newer Spring security versions. Older style configuration. In older Spring security setups, using Web Security Configurer adapter, you may see something like this. Override. Protected void configure HTTP security HTTP, throws exception, HTTP headers, frame options, disable. Example concept. Older syntax means disable frame options through chained configuration. This was common in older Spring Boot and Spring Security versions. What happens after disabling it? After disabling frame options, Spring Security stops sending the X-frame options header. Example concept. Before disabling means response contains frame restriction. After disabling means header removed. This allows browsers to load the page inside a frame or iframe, assuming nothing else blocks it. When this is commonly used, disabling X-frame options is commonly used for H2 console access, internal admin pages, embedded app interfaces, development testing scenarios. Example concept. Special use case needs frame rendering means developer disables frame protection. But it should be done carefully. Better option in some cases, sameOrigin. Sometimes you do not want to fully disable framing. Instead, you only want to allow framing from the same origin. That is more secure than complete disabling. Example. Bean, public security filter chain, HTTP security, HTTP, throws exception, HTTP headers frame options, sameOrigin. Return HTTP build. Example concept. Allow same site framing only means safer than allowing all framing. This is often a better choice for H2 console and internal tools. Why sameOrigin can be better? SameOrigin means the page can be framed only by pages from the same origin. In simple terms, same application/site can frame it. Other sites cannot. Example concept. Your app frames its own page means allowed. External attacker website frames your page means blocked. So, this is often safer than completely disabling frame protection. Common H2 console setup example. For H2 console, developers often need both. Permit access to H2 console / allow frame rendering. Example. Bean, public security filter chain, HTTP security HTTP throws exception. HTTP authorize HTTP requests, auth request matchers, H2 console / permit all. Any request authenticated. Headers frame options.sameOrigin. CSRF.CSRF.disable. Ignoring request matchers /H2 console. Return http.build. Example concept. H2 console permitted plus CSRF adjusted plus frame allowed from sameOrigin. This is a very common Spring Boot setup during development. Why disabling completely may be too much. If all you need is local or same site framing, fully disabling the header may be more permissive than necessary. Example concept. Need limited iframe support means full disable removes all protection. So many times the better solution is use sameOrigin. Avoid full disable unless required. This is a better security practice. Modern Spring Security, Lambda style. Modern Spring Security uses Lambda-based configuration. For disabling frame options, HTTP headers.frameoptions.disable. For allowing sameOrigin, http://headers.frameoptions.frameoptions.sameOrigin. Example concept. Modern Lambda syntax equals preferred configuration style in newer Spring Security. This is what you should usually use in newer projects. What if it still does not work? If disabling or changing frame options does not solve the issue, other causes may exist. Possible reasons include CSP frame ancestors policy blocking, framing browser restrictions, reverse proxy, adding headers, custom filters, adding security headers, another security configuration, overriding the setting. Example concept. X frame options disabled, but something else still blocks iframe rendering. So, if framing still fails, inspect the full response headers in the browser developer tools. Important note about Content Security Policy, CSP. Modern applications may also use Content Security Policy with rules like frame ancestors. Even if X frame options is disabled, a CSP rule may still block framing. Example concept. X frame options removed means browser still blocked by CSP frame ancestors. So sometimes the issue is not only Spring Security frame options. Common beginner mistakes. Here are some common mistakes. 1. Disabling frame options without understanding the security risk. This may expose the application to clickjacking. 2. Fully disabling when sameOrigin would be enough. This removes more protection than necessary. 3. Forgetting to permit H2 console paths. Frame settings alone may not be enough. 4. Forgetting CSRF issues with H2 console. Some H2 console setups also need CSRF adjustment. Ignoring other headers like CSP. The problem may not be X frame options alone. Best practice. The best practice is do not disable X frame options globally unless necessary. Prefer sameOrigin when it solves the use case. Use full disable only for specific trusted scenarios. Be extra careful in production applications. Example concept. Need iframe support means choose the least permissive, safe option. This gives better security and cleaner configuration. Advantages of understanding this topic. Advantages include better understanding of Spring Security headers, easier setup for H2 console, safer iframe configuration, improved REST and web security awareness, better protection against clickjacking mistakes. Example concept. Understand frame protection means configure security more safely. Challenges. Some challenges include balancing functionality and security, understanding browser frame protection, handling different Spring Security versions, diagnosing header conflicts with CSP or proxies. Example concept. Framing issues may look simple, but several headers can affect the final behavior. Concepts learned in this topic. By learning this topic, you understand key. What X frame options is, why Spring Security adds it, what clickjacking is, how to disable X frame options, how to use sameOrigin instead, why sameOrigin is often safer than full disable, how H2 console is related to this issue, why CSP may still affect framing. This gives you an important practical Spring Security skill. Simple definition. Disable X frame options in Spring Security. The process of configuring Spring Security to stop sending the X frame options header, allowing pages to be displayed inside frames or iframes. Final summary. To disable the X frame options response header in Spring Security, you typically configure HTTP headers like this. HTTP headers frame options disable. This removes the frame protection header from the response. However, Disabling it completely is not always the best choice, because the header helps protect against clickjacking attacks. In many cases, a better option is http://headers, headers.frameOptions, frameOptions, sameOrigin. This allows framing only from the same origin and is often enough for use cases like the H2 console. The key idea is X-frame options protects against clickjacking. Disabling it allows iframe usage. sameOrigin is often safer than full disable. Production systems should be careful with this setting. Once you understand this topic, you can configure Spring Security framing behavior much more safely.